Hello guys, today's new topic is symmetries of the unit circle. Actually, in this topic we're gonna learn how to express any angle in the form of in the acute angle or less than in the 90 degree of the triangle. For example, if we have given degree of 60 and here will be right triangle and here will be 30 degree. So if we have asked guys to find cosine of 60 degree, what's the cosine of 60 degree? It's here, yes, it's here, cosine of 60. So what about the sine of 30? Sine of 30 degree. Sine of 30 degree, we have to show in the form of there will be 30 degree, the half of this 60, and will be approached to the sine, and here we'll show you sine of 30 degree. So it's our result. So as you see, by this triangle we know that if here is 90 degree, 60 and 30 degree, the opposite side of 30 is a, the opposite side of 60 is a root of 3, and the hypotenuse will be 2a. According to this triangle, we know that, and according to the last topic ratios, we know that cosine 60 is the adjacent over hypotenuse. Or in other words, the adjacent of this 60 is a and hypotenuse 2a. So we get answer 1 divided by 2. So here sine 30. Sine 30 is also, this is the formula of this is opposite over hypotenuse. And opposite side of 30 degree is a and divide to hypotenuse, and you will get answer a divided by 2a, or in other words 1 over 2. So guys, as you see, the cosine 60 and sine 30 are equal. So actually I want to show you the equivalence of these two ratios, cosine 60 degree and sine of 30 degree. They are, as you see, equal. So guys, as we said before, cosine 60 degree is equal to the sine 30. Why? We now show you why they are equal. Because we have given this triangle, and this part is, as we know, cosine 60, and this part is sine 30, or 1 over 2. Okay, so if we draw another part of this the quadrilateral, we get 60, here will be 30 degree, and 30, in order to get 90 degree, it will be, so here formed another triangle with the same angles. So 90 degree, 60 degree and 30 degree. So let me, dear friends, show you the equivalence of sine and cosine in the right triangle. So if we have given, for example, alpha angle, it's our first quadrant, and alpha angle will be here, and if we approach it at here will be cosinus alpha, and here will be sinus alpha. But we have to find the relation between sine and cosine. For example, cosinus alpha here in the right triangle, we know that the formula of this cosinus alpha is the adjacent over hypotenuse. Or in other words, the adjacent of alpha is A, and you'll divide by the hypotenuse, or in other words, h. So next, what about the sinus 90 degree minus alpha is equal to sinus? What's the formula of sinus? Is the opposite over hypotenuse, and this opposite adjacent will depend on the angle, because the opposite angle of this 90 degree minus alpha is the opposite is, look, here is A. So A divided by hypotenuse. As you see, guys, cosinus alpha and sinus 90 minus alpha, they are equal because of the ratios, because the values, for example, cosine 60 degree is equal to sinus 30 degree, okay, because here 60, and if you subtract 60 from 90, we'll get answers as 30. For example, sinus 45 degree is equal to 90 minus 45 will be 45. So they are equal, guys. So next, for example, cosine 53 degree is equal to, here will be 53, and just replace 53 to the alpha, and if you subtract 53 from 90 degree, you will get answer sine 37. So we have put these equivalents. So if I asked you cos 90 degree, 89 degree is equal to sinus 1 degree. So they are all equal ratios or equal values. So in the next example, I will show you, for example, theta given 120 degree. So first you have to show this angle in the unit circle. So it's the less than 180 degree but bigger than 90 degree. So it's in the second quadrant, or in other words, it's approximately here, and all this angle will be 120 degree. So we have to find sinus 120 degree. So it's approximately here, but in the if the angle is in the second quadrant, we can reflect it. Reflects like this. Look, they are equal. Till here we have angle 120 degree, and in order to the half rotation of on a line will be 180 degree, so the rest part is 60 degree. Okay, so starting from origin from 0 to here is also 60 degree. Look, guys, this slide asks to find 120 degree. It's, we know, sine 60 degree. They are equal. Why? Because if you will find sines of 120 is, you will approach to the 120 degree and the angle will be here, and if you approach this angle to the sine, so sine 120 will be here, as you see. So what about sine 60 degree? It's also here. Why? Because if you approach 60 degree, the line is here, and if you approach this angle to the sine intercept, it will be here. So these values are equal. So we gonna show it in that way. So next, guys. So in this example, I'll show you the cosine. So as you know, the cosine is this line. Am I right? So here is 0, and it will to the right will be plus infinity, or this point is 1 and this point is minus. So 120 degree is, let's theta angle will be 120 degree, and so cosine 120 degree will be here, cosine 120 degree. So what about the cosine 60? Cosine 60 will be here. So are they equal, guys? Your answer? No, because as you see here, this part in the cosine in the second quadrant is negative, as you see, because it will start from 0 to the minus infinity. So here will be minus, okay? So this expression is right, they are equal.